For life to grow and thrive, and for poverty to decrease, communities need robust clean water facilities. Tanna Island in Vanuatu faces significant water shortages due to natural disasters and a growing population, which is reflected in decreased social and health outcomes, including poverty and gender inequality. To combat this issue, the government of Vanuatu, in collaboration with WHO and DFAT, initiated a pilot program in 2016 to provide a first flush rainwater system in 7 locations across Vanuatu, including 2 locations on Tanna Island. However, 38% of water systems across the islands of Vanuatu were found to be in need of repair or not operating at all in a rural water supply audit, highlighting that it is not enough to simply implement infrastructure. As the government looks to roll out these systems across the country, an effective and efficient way to maintain and operate these systems in rural and remote areas is integral. Comprised of local people, rural water supply committees are responsible for the management and operation of water infrastructure in Tanna. However, a lack of capacity and organisation presents challenges to their long-term operation. The introduction of an altered system is proposed to improve the process of maintenance through automation, whilst simultaneously engaging marginalised populations into water quality management through consultation, education, and the provision of opportunities for ongoing management.
The passive first flush system diverts the initial rain volume and any sediment that has been washed off the roof, preventing the greatest pollutant load from entering the tank. Sediment must be manually removed and cleaned out at the end of each storm event. Otherwise, the first flush pipe becomes blocked, resulting in the contamination of the entire storage tank. Due to the inconsistent timeframes between required cleanings and inability to visually recognise the problem, the issue often passes under the radar of community water councils. Our proposed solution is a sustainable and cost-effective self-cleaning amendment to the existing first flush system, built to last in the harsh environment of Vanuatu. 2 springs and 2 magnets will be used to create a base cap that lowers when the water and sediment column exceeds a mass threshold and closes and reseals after a small amount of water and sediment are expelled. The springs are fastened to the downpipe and the base cap, while the magnets are attached to a sediment diverting cone on the base cap and a submerged crossbar fixed in the downpipe. To reduce potential faults within the mechanism, a silicon pad has been attached to the fixed pipe magnet to prevent them from dislodging and cracking, and the base cap has a steel cone which directs sediment outwards, preventing the accumulation of sediment along the pipe walls.
Whilst adding a mechanism to the first flush system will decrease the manual cleaning, the addition of moving parts increases the complexity of the system. To ensure any failure of the first flush system can be recognised and successfully mitigated in a time-sensitive nature, a turbidity meter will be installed into the side of the water tank prior to use. As you can see here, when the red pattern is visible, the system is running, and when the red pattern is no longer visible, this will notify the community members of an issue. This will allow for early intervention by Water Council members, decreasing the risk of further contamination issues. A picture-based instruction sheet will be produced in collaboration with the Water Council and community to visually represent the water in both situations and provide easy-to-follow instructions to encourage community participation in ongoing maintenance of the system. The simplicity of the water monitoring solution allows for a wider cross-section of society to contribute to the dialogue around water quality and its management within the community. This offers women and people with disabilities an opportunity to participate in communal responsibility in the traditional villages of Tanna. This aims to empower and build capacity in marginalised populations through knowledge provision regarding the implementation of the proposed first flush mechanism and the visual turbidity measurement device. The updated system aims to reduce the need for manual cleaning of the first flush system and increase the lifespan and integrity of the water tank. This in turn promotes sustainable and economic and environmental outcomes suitable for greater implementation of the project across wider Vanuatu. Decreasing the requirement of the neglected monitoring tasks and providing an opportunity for minority groups to participate in water management will ultimately improve the operation of water infrastructure for remote, dispersed and isolated populations across Vanuatu.